Okay, so now students, we are going to look at use of salting to kind of make it difficult for an attacker to crack a password. So the motivation for to do salting was if two users end up choosing the same password, the hash value of the password will be the same because they use the same password. So we want to kind of make it difficult for an attacker. So even if two users choose the same password, the hash value of the passwords will be different. So for that, what we do is we choose what is called as salt value and pass the salt value to the hashing algorithm and generate the hash value. So if even two users choose the same password, their salt value, if it's different, the hash value is going to be different. Okay, so now when we look at the math problems behind this, we want to find the number of hash computations to be done if we use salt and we don't use salt. Okay, so let's start with the traditional approach where we do not use any salting. So again, what was the strategy we had? For every word in the dictionary, compute a hash value and see if it matches with any of the hashed passwords in the password file. So if we don't use any salting, then for every word we do one hash computation and see if it matches with anything in the dictionary, in the password file. Okay, so number of hash computations per word in the dictionary is 1. So at the worst case, you have to try all the words in the dictionary, find the hash values and see if they match here. So at the worst case is the dictionary size times the number of hash computations per word in the dictionary. So it is 2 to the 20 times 1, which is 2 to the 20. And on average, we do half of this. Okay, so that's 2 to the 19. Now, if we use a salt, right, to compute the hash value, then the salt values could be either publicly listed in the password file along with the hashed password, or it may not be publicly listed. Okay, so in either case, in both cases, the number of different salt values we can have is based on the number of bits. So if I use a 12 bits for the salt value, then the number of different salt values I can get will be 2 to the 12, because the range of the salt values can go from 0 to 2 to the 12 minus 1. So which means for every word in the dictionary, I have to compute multiple hash values because they could have been hashed with different salt values. So now we have to look at the scenario where the salt values are publicly listed along with the username and hashed password in the password file, or they are not publicly listed. Okay, so if they are publicly listed, all right, so for every word we need to know what are the possible salt values could have been used. And since the salt values are publicly listed, those are the salt values that would have been used to compute the hash value of those words, if at all they have been used from the dictionary, right? So how many such salt values are there? If they are publicly listed, again, the number of salt values that would have been listed there would be the number of user accounts there. So in this case, if there are 2 to the 10 user accounts whose hashed passwords are listed, you would have listed that many salt values. So the number of hash computations you have to do per word in the dictionary is either the number of salt values that are listed over here, that is the number of users, or it could depend on the number of different salt values. So which one will have to use? It depends on minimum of the two. Why? If there are only 2 to the 10 users, which is less than 2 to the 12, then you don't have to try with all the 2 to the 12 salt values for every word in the dictionary, because we know these are the actual salt values that have been used, right? Sometimes they could be repeated, sometimes they could be distinct, because we have 2 to the 10 different users and you could have used 2 to the 10 different salt values from this range. Alright, so the worst case, all the 2 to the 10 salt values would have been different and we would have used that many users, right? Now, why we take a minimum? For example, if the number of users is not 2 to the 10, let's say it's 2 to the 1000, right? Then we don't need to do 2 to the 1000 hash computations, because we know the maximum number of different salt values we can have is only 2 to the 12, which means certain hash values would have been repeated. So that's why I had a 1234 before. Okay, so that's why we take a minimum. We cannot go beyond this many salt values. 2 to the 12 in this case is the number of different salt values we can have. So it depends on either the number of users or the number of salt values. The minimum of the two would be the number of hash computations that you have to do at the worst case for every word in the dictionary. Right, so the worst case number of hash computations to crack a password is then the dictionary size you are multiplied by the worst case number of hash computations for every word in the dictionary. So in this case 2 to the 20, which is the dictionary size, multiplied by the minimum of the number of users, 2 to the 10, comma 2 to the 12, which is the number of different salt values. Okay, so again for every word, once you know what are the different salt values used, we have to use that many uses, right? So we are trying to minimize the number of hash computations. So at the worst case, if you have number of users less than the number of salt values, use that many uses, or if the number of users is greater than the salt values, use that many different salt values. Okay, so that's what it is. So minimum of this is 2 to the 10 times 2 to the 20, which is 2 to the 30, and on average we do half of this, so it is 2 to the 29. Now if the salt values are not publicly listed like what we had before, then we don't know what salt value would have been used for every word in the dictionary. So pick up each word in the dictionary, hash it with all possible salt values, and all possible salt values are 2 to the 12. So we cannot save some time here because we don't know what salt values were used. The previous case we did know what salt values were used, so we used only that particular salt values. And in this case we have to try all possible salt values, so that's why the number of hash computations you use per word in the dictionary at the worst case is number of salt values. In this case it is 2 to the 12. And to crack the password, it's the dictionary size. In the worst case, you have to try all words in the dictionary times 2 to the 12, so it is 2 to the 32. And on average, you do half of this. Okay, so as you see here, the traditional approach you require 2 to the 19 computations. With the salt values publicly listed, you require 2 to the 29, and with the salt values not publicly listed is 2 to the 31. So you see the complexity increases when we do salting. Okay, of course when you don't list them publicly, it is even more difficult to crack, like 2 to the 31 compared to 2 to the 29. Right?